let's switch to the slides just for a little bit. And again, all this progression with the string design that mimics Java-like string in C++. This phase of development was to demonstrate that sometimes we need to add a destructor to our classes. And this is a C++ feature, the function which is invoked at the time when the object is destroyed. So destructor is called when it goes out of scope. Now, if you recall, we had this example of chain of constructors, which we specified is a predictable sequence of constructor calls when we have an object containing sub-objects. And if you compare these two sequence diagrams, the call of destructors or the chain of destructors is also totally predictable. Basically, if the wheel object was constructed at the very end of this moped or scooter object construction, now it will be destroyed immediately. And we had two of them, so they will be destroyed in the opposite order. Then the transmission, and then the engine, and then before the engine is going out of scope, we're going to also destroy two of the cylinders. Okay, so this is just a correspondence between the chain of constructors and chain of destructors in terms of timing and their order of execution. Destructors are always invoked at this stage, because, for example, if I run this program, if I just make sure that I built everything so it's already up to date, if I set a breakpoint on this line and press F5 to start debugging session, and of course it prints all of this, but now I stopped before printing the last line, so I'll just step over this line right here by pressing F10 like this, and you can see that we printed it the second time. And then we return, and upon return, if you watch carefully, press F10 once more, and we do not immediately return from here. On this closing brace, all objects that were created in the scope of main function will be destroyed. This closing brace is responsible for invoking destructors for all of our strings that we managed to create so far as local objects inside the main function. So if we press F11 or if we add another breakpoint to this destructor, you will see that the destructors are invoked at this stage. We could even add some tracing messages to this destructor. But that's my point, is that when you say return, technically speaking, you do not return immediately out of function. There is a go-to transfer of control to this closing brace, and this closing brace is compiled so that it will invoke destructor for every local object that we create right here. So hello, greeting, and hello, hello. Destructors will be invoked right here, right about now. So we can test it. I think best to test this, I'll just go debug, stop debugging. I can test it by inserting this output statement just for the sake of debugging, and print function name, which is __ function. It's typically most compilers define this macro when you run the compiler that contain the name of the function, and we'll just print new line right here. So if we build this program again, and run it again, you will see that this destructor right here, the destructor that we defined, is being invoked quite a few times. So when we create temporary objects and destroy them, they're all destroyed. And so we will revisit and find out what these things are in the middle of our run. But at the end, I can assure you that these three destructors are actually the result of destruction of hello, greeting, and hello, hello, because these are local objects. So let's try to see this in debug session one more time. I press F5, which runs to here, press F10, return, one more F10, and right now this is where it got printed. As soon as we landed up on this, between return and this, in the step of transferring control from return to this closing brace, these three things are being printed, because this is the destructor invocation for hello, greeting, and hello, hello, the three string objects that were created locally in this context. Okay, so I'll just say debug, stop debugging, and this is part of this discussion on the chain of destructors, that all destructors are actually always executed in the opposite, exact opposite order of all constructors. So there's an example of a destructor using a point class, a small class with two integers, and a destructor defined right here. So this is, of course, looks very similar to our definition of destructor that does all of this. And a few notes that destructors are invoked when an object goes out of scope. We never call them directly. They do not take any arguments, so their signature, they don't have any parameters. And they never return anything. Just like constructors don't return anything, there is no return type of constructors. Destructor also does not have any kind of return type. So using destructors will be called for any object at the end of its life cycle, and these are all the highlights that we already specified. And very typically, when we're freeing memory allocated with new, so we want to make the object responsible for newly allocated memory. And in our case, we gave this responsibility to brand new constructed string. And since we use this new and remember the pointer to memory allocated dynamically, hopefully this string will be able to destroy that memory in appropriate manner. Sometimes objects open files, and files have to be closed, otherwise unclosed files will create a resource leak. And if this is some kind of server software, it needs to be able to deallocate resources. Again, a destructor would be a perfect place to deallocate other dynamic resources, such as open files, open devices, open network connections, things of that nature.